Today we're going to continue to talk about quadratics. We're going to use the skills that we have accumulated so far with factoring to help us actually solve, which means to actually determine what x does equal, which is something we haven't done so far, at least not in this class. So to do that, we just got to go straight into an example. In this example of x squared plus 5x minus 14, we're going to want to try to factor that first part of it, that trinomial, to figure out what the x could be. We do that just like we've done with all the other problems. We think about what are the possible factors of 14. Of course, we have 1 and 14, but we also have 2 and 7. Remember, we want to check it to the 5. The only way to make a positive 5 would be to have negative 2 and positive 7. So that's the combination for my factors. I have an x minus 2 and an x plus 7. The only difference now is it does still equal 0. By equaling 0, it makes this problem actually solvable. The only way to create a 0 by doing the multiplication of these two parentheses next to each other is if whatever is in the first parenthesis equals 0, or maybe whatever is in the second parenthesis actually equals a 0. Because the only way to make a 0 from multiplication is to multiply by a 0. So we have two hypothetical situations. Maybe the x minus 2 is actually the 0. Or maybe the x plus the 7 is actually the 0. This gives us two very tiny and very quick simple problems to do. In this problem, we're going to add 2 to both sides, and my final answer is x equals 2. In my other problem, I minus 7 to both sides, and my final answer is x equals negative 7. So when you solve a quadratic, you actually end up with two answers, not just one answer for x. It could be the case that the number in both sets of parentheses are the same, and then you might actually end up with the same number twice, or really just one number. But most of the time you're going to see a situation like you just saw right now, with two distinct answers for x. You only do this if the problem says equal 0. Let's try one of those problems where we have a number in front of the x squared, such as this 2. Before you try any kind of factoring or any kind of a times c or all those skills that we've tried to get better at, look to see if there's a GCF. 2, 6, 8. There is definitely a GCF here. So this problem, I want to use the GCF method. This GCF is 2. Let's pull out a 2. 2 times x squared, 6 divided by 2 is 3, and 8 divided by 2 is 4. Don't forget, there's still a 0. And also don't forget, your GCF goes in front. Now, I want to try to factor out this problem. Now let's ask ourselves, what are the factors of 4? The factors of 4 are 1 and 4 and 2 and 2. I want to make sure that it's going to add or subtract a 3. Let's use the 1 and the 4. Let's make it a positive 4 and negative 1, and that will give me my 3. My factors are x minus 1 and x plus 4. Don't forget your equals 0, and also don't forget your GCF in the front. Now I do want to make sure this 2 goes away, but that's a very simple, quick step. That step is just to divide by 2 on both sides. 0 divided by 2 doesn't actually do anything. It still says 0. So now I have x minus 1, x plus 4 equals 0. Let's write down our two little mini problems. X minus 1 might be the part that creates the 0 that multiplies to equal 0. Or maybe x plus 4. Maybe this part is the 0 that multiplies to make 0. I add 1 to both sides, and my answer is positive 1. I minus 4 to both sides, and my answer is negative 4. My two answers are positive 1 and negative 4. Do notice that these answers are the opposite signs of the factor numbers that you had to create the factoring. This is our last example for this video. In this situation, I look across the 3x squared, the 13x, and the 10, and I'm not really noticing any kind of GCF. So I'm not going to try to pull out any numbers. Instead, let's try to factor it with the A times C style from the last video. A times C in this problem is 3 times 10, which is 30. What are the possible factors of 30? Well, one combination, of course, is 1 and 30. Another combination is 2 and 15. We could also have 3 and 10. And we could also have 5 and 6. Which one of these combinations actually creates the 13x in the middle of the trinomial? I think that's going to be the 3 and the 10. But the problem with the 3 and the 10 is the fact that if I take 15 and minus 2, well, that would also be a 13. The reason why this is happening is because I didn't consider the fact that this was a negative 10. So do be aware, as you do problems, you should always carry those signs with it. So really, I want to make a negative 30. So one of these has to have at least one negative and one positive. So if I try one negative and one positive on 3 and 10, I end up with 7. This isn't going to work. But when I try a positive and a negative on 2 and 15, I end up with my 13. This is the combination that should split the 13x up into two pieces. Splits up into a negative 2x and a positive 15x. Don't forget that following the 13x is a negative 10. So following these two is also the negative 10. And coming before it was the 3x squared. Time to cut our problem in half and look for GCFs. The GCF in the first two terms is x. Pull it out and you end up with 3x and a negative 2. GCF in the second two terms is a 5. A positive 5 or a negative 5? Well, let's try a positive 5. 15 divided by 5 is 3x. 10 divided by 5 is 2, negative 2. I did end up with the same exact 3x minus 2 in both sets of parentheses. That means it is definitely a part of my factors. And the other factor is the GCF, x and 5. Notice in every single step I've done during the factoring, I've kept the 0, kept the equals 0, kept the equals 0, because now it's time to make two little mini problems. First mini problem is 3x minus 2 equals 0. Second mini problem is x plus 5 equals 0. X would have to be equal to negative 5 from subtracting 5 on both sides. Let's add 2 to both sides and end up with 3x equals 2. Divide by 3 on both sides and x equals 2 thirds. 2 thirds and negative 5 are my two answers for x. So really, your success in this skill is to really be good at factoring, to understand the multiple methods that we use for factoring. Once you have that down, we use it and create two little mini problems that are both equal to 0 and that are very quick and easy to solve and get our answers. If you have any questions, make sure you write them down in your left-hand column and be ready to share them with your groups in class. Also, do not forget to hit the continue button at the bottom of the video answer the quick questions, and then hit submit so I have record of you watching this video and taking this set of notes. I look forward to seeing you in class.